In this video, we will discuss the law of superposition, detailing what it is and highlighting why it is important in the context of an example from mechanical and electronic engineering. Let's first delve into why this is a useful idea. At A level, problems are often one-dimensional, and there are only a handful of factors to consider. Real problems are far more complex, and stimuli can result in a combined response, which can give a very different model than if any one of the factors were ignored. Let's now look at the law of superposition as a mathematical rule. We can see in terms of mathematical functions how a function of a and b can, for linear systems, be considered separately as functions of a and a function of b, and the response from these being added together to give a resultant function. Note that this only works in the case of linear systems, and many systems are approximated to be linear to make sense of nonlinearity, but we won't go into that in this video. This point is made clearer with an example. This relies on algebraic manipulation, which is amongst the first lessons taught in algebra. We have 4 lots of 10 being equal to 40. However, 10 is also equal to 8 plus 2. So we can see that 4 lots of 8 plus 2 can be separated into 4 lots of 8 plus 4 lots of 2, which does equal 40 by the law of superposition. If we break down what has just happened, the function is multiplying the part in brackets by 4. Stimulus A has given a value of 8, and stimulus B has given a value of 2. The function y equals 4x is a linear function, and so what is not a surprising outcome has resulted in showing how the law of superposition works. Part of our aim to bridge the gap between school and real-world engineering is to start giving some kind of intuition as to where some of the knowledge built up through your education so far can be applied to a possible solution to a real problem. An area in which superposition is useful is in stress analysis. The combined effects of strain due to forces in given directions, how a material transmits forces in other directions, and material properties can be combined to create an equation which will give a more accurate picture of strain on a material element. We can see that strain being equal to stress divided by Young's modulus is one of the stimuli, but the other stimulus is due to Poisson's ratio, a material property which suggests how much changes in one direction of a material influences changes in the other direction. Another area in which superposition is useful is in circuit analysis techniques. At A level, it would seem as if you had the skills to analyze any circuit. However, there are specific component configurations which make it difficult or near impossible. A useful tool is to consider each circuits with many sources by focusing on one component at a time and then adding the resulting output, taking care as current and voltage are vectors and so have both magnitude and direction. Here, the current source is introduced as it is a useful concept which will be explored throughout any future studies. These examples are simply meant to give you some intuition as to where the law of superposition is useful in engineering. We will go into more detail in later videos on mechanical and electronic engineering. We conclude this video with some final remarks. A-level focuses on finding and explaining critical values, but systems are often one-dimensional. We progress to considering more complex systems that are difficult to consider by considering changes in just one variable at a time. We begin to consider such systems by utilizing the law of superposition. Don't forget to like and subscribe for more.